Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening.
Waalaikumsalam, Prof. Evening.
Okay, so we will continue our class. Okay, so for today, I will discuss on guideline for slope design. Okay, actually, I obtained this information from the slope uh, branch. Okay, from slope engineering branch. Okay, under Department of Public Work Malaysia. Okay. Uh, okay. Okay, so a brief introduction on this design guideline. Okay, so in 2004, Malaysian government directed Public Work Department of Malaysia to establish a new branch called the Slope Engineering Branch. So this branch has been involved in mitigation, research and development, risk management, safety and planning on slope. The guideline was prepared by the Slope Engineering Branch, Public Work Department of Malaysia. It is to be used as a supplement to other geotechnical manual, such as Geotechnical Manual for Slope, published by Geo Hong Kong, British Standard, and other accepted standard practice. Okay. So in Malaysia, okay, we need to refer for a special guideline, okay, prepared by the Slope Engineering Branch. So actually, I also refer to the Geo Hong Kong Geotechnical Manual. Okay, so it's very what we call as very thick of manual compared to this manual by the Public Work Department of Malaysia. Okay, so if you are interested, I can also share the Geo Hong Kong manual, okay, in the e-learning, so you can go through the manual. Okay, so most of the investigation carried out thus far revealed the cause of landslide were due to physical, geological, and human element. Okay, so from this guideline, okay, so they has identified the three major causes, which is the physical, geological, and human elements. Okay. So physical, most probably due to the slope geometry. Okay, so might be from due to the rainfall and cause uh, the the water, okay, infiltrate inside the slope and then cause the increment of load, okay, due to the development of the pore water pressure. So geological most probably refer to the type of the formation, okay, and human element, okay, most probably due to the development which is not conduct properly. Okay. So based on landslide forensic statistical data for large scale failure from year 2004 to 2007, okay, if I'm mistaken, this guideline has been formed 10 years ago, okay, and we share also the exactly guideline in the e-learning after class. Okay, it was found that about 57% of landslide were due to human factor, whereas 29% were attributed to the physical factor, and 14% caused by various geological factor. Okay. So it was also discovered that most of the landslide occur at a main mid slope. Okay. So this table just shows some of the uh, the uh, the data, okay, for the landslide event. Okay. I guess which is based on what we call as the major landslide event, okay, that cause of fatality or fatalities, damage, okay, So for example, for the first one, slope failure at Taman Harmonis, Gombak, Selangor. Okay, one fatality and one bungalow damage. Okay, so this is due to the human factor. Okay, so the human factor cause the most contribute for the most landslide event. Okay, so there are another slope failure at Kampung Pasir, Hulu Kelang, which is due to human factor. Slope failure at kilometer 8.5 Jalan Persetuan, Sepanggar, Sabah. Okay, physical factor, most probably due to the what we call due to the geometry of the slope, okay, or the rainfall event. Wangsa Maju, okay. Another one in federal government quarters. Slope failure at kilometer 100 Jalan Persetuan, Butterworth to Ipoh. Slope failure at Bukit Kapit, Sarawak. Okay.
Doctor,
Ah,
meaning that this particular branch have all the database of the current slope failure up until today, right?
okay, actually this branch only cover for the Jalan Persetuan. Okay.
Oh.
So for instance, if the landslide happen at for example at the forest area, okay, so most probably Jabatan Perhutanan will react on this issue, or GMG. Okay. Okay, from my experience, okay, from the last Yan Kedah event, okay, so Jabatan Perhutanan, the forest department, forestry department, okay, and also the JMG, okay, mineralogy and galian department, okay, is the main the main department that in charge for that kind of investigation. Okay, so because they call it CKG and CKC, Cawangan Kejutaan Curun, or Slope Engineering Branch. Okay, because it is under JKR, Public Works Department. Okay, so
Yeah. And then memang
they
patut
cater
pun
most.
sorry Doctor, proceed.
Ya, itu kan.
Oh, maksudnya you mentioned JKR, so any meaning that all the roads yang under JKR sahaja yang under their surveillance lah.
Yes.
Oh, okay.
Okay. But they can also give any opinion or suggestion. Okay. Actually, I have my the academician clique and me, okay, has formed what we call as a consortium, okay, to help the CKC, where we form what we call as IPTA, Institute Pengajian Tinggi Awam Consortium for the Landslide. Okay. So we will help CKC, okay, Cawangan Kejutaan Slope Engineering Branch, okay, for example, to provide a training, okay, to provide what we call as a research and also to give any consultations in regard to the slope event or landslide event. Okay, so the main objective for formulating this guideline are to stipulate guiding principle to JKR, okay, which is Public Works Department and other engineer involved in slope design. So to minimize in slope failure disaster, to increase stability of slope, to create awareness of the risk involved in slope design, to further enhance existing geotechnical requirement in slope design. Okay, so this is the objective of this guideline. Okay. So the methodology used are study of landslide forensic statistic, adopted factor safety from international standard such as from the Hong Kong and British standard, study of existing typical cross-section of slope features, study of SI requirement, drainage system, survey data, review of historical data or records such as design report, as-built drawing, survey data, SI, and etc. Okay. So I guess by referring to the Hong Kong and the British standard, so they prepared this guideline. Okay. So, okay, this is the designer responsibility. Okay, designer shall search and study or report on feasibility study, development plan, and investigation related to the work so as to enable full understanding of factors which may affect the works. Notwithstanding, requirements stipulated herein, the designer should satisfy the aspect of aesthetic, functional, and safety requirement, suitability and effectiveness completed to the intent of the works. So this is a general responsibility for the designer. Okay, especially for the slope design. Okay, for the surveyor, the designer should carry out detailed topographical, okay, hydrological and land survey of the proposed site and area that may be affected by the work, which may be necessary to supplement and available survey information for satisfactory execution of design and construction of the work. Yeah. So they need to carry out for several survey. Okay. For example, the most important survey maps that we need is the topographical, because we want to identify the geometry of the slope. Okay. Hydrological, okay. So we want to understand the nature of that particular area. Okay. Survey plan shall be prepared in scale appropriate to their purpose and follow the guideline for presentation of engineering drawing. Okay. So we need to refer to Arahan Teknik Jalan 6/86/85. Okay, the designer should be responsible for the accuracy of survey data that is used in design work. So this is the guideline for the site investigation. The designer should undertake his own additional soil investigation and material survey for the purpose of preparation of the engineering design and construction of the work. The preliminary site investigation result is provided by the client to be used as the preliminary or general guide only. The client is not obliged to guarantee the completeness and accuracy of the preliminary soil investigation result. All site work should be complied with. Okay. So means that the designer, I guess during the tender process, okay, so a pre-site investigation work will be carried out. Okay. So later on, after they has awarded to the, for example, to the consultant. Okay. So they can use the result from the SI, okay, but they also should carry out for any additional soil investigation work. Okay. So design data or design of the technical design should be based on the data interpreted from the preliminary SI report and any additional soil investigation carried out by the designer. All details should be accompanied by a summary of the result of the field exploration and laboratory investigation. Okay. So this is all the parameter, okay, that should be obtained, okay, from any site investigation work. Okay. So I guess the most important thing is to know what is the shear strength parameter, okay, of the material. Okay. So when we want to design by using any software, so we need to include or to put the input of the strength parameter inside the software. Groundwater level is also important. Okay, I will discuss later on the instrumentation. Okay, to determine the groundwater level. Okay. So engineering geological mapping and investigation. Okay, so this is related to rock slope. Okay. Independent geological mapping of the subject area should be carried out on an appropriate scale, okay, which shows sufficient detail to adequately define the geologic condition, okay, present such as rock type, structural geology and nature of the rock slope and groundwater condition. Existing geological map should be treated as a basis for understanding the site condition. If available geological maps are used to portray site condition, they must be field checked, updated to reflect geology, topography or change which have occurred since the map publication. It is necessary for geologists to extend mapping into adjacent area where mapping not be carried out previously to adequate define geological condition relevant to the project area. So actually for the rock slope, okay, so yeah, if we want to refer to the geological map, okay, from the JMG, okay, so that is the uh, uh, that is the way that we can obtain all this geological information. Okay, so another thing is to they also call as a geological map. Okay, when we try to investigate what we call as the surface of the slope, okay, for the rock slope, okay, we want to identify the deep direction, okay, the discontinuity, okay. So we also refer that as a geological map, okay, when we want to portray the surface of the rock slope, okay. For the rock slope and adjacent rock exposure, discontinuity data collection and analysis should be carried out to aid identifying the possible mode of failure. Okay, so this is another way that we want to explain on the geological map. Okay, rock outcrop mapping is the best field way to obtain discontinuity data. If little of no exposure is available in the slope, knowledge of local geology may permit extrapolation from the outside of the slope. So I have what we call as experience. Conducted a study on the rock formation and on the rock slope. Okay, at the Plus highway. Okay, if you are familiar, after the Ipoh, there is a Menora tunnel. Okay, so after the Menora tunnel from Kuala Lumpur, so we can see a lot of rock slope, okay, on our right side. Okay, if we are from Kuala Lumpur heading to the north. Okay.
Is it granite, doctor?
Granite. So Plus awarded some grant, okay, to us, and then we carry out for the analysis. Okay, and then we use what we call as TLS, terrestrial laser scanner. Okay. At the same time, we also use the conventional way, okay, by using the Brunton compass. Okay. So then we also use the UAV, okay, the drone, okay, to capture for the rock surface, which is not able to be covered by the TLS. Okay. So after completed the first job, okay, in at the Jelapang, okay, so then plus award again 2 more rock structure, okay, which is at the Bukit Merah. Okay. If you are familiar with the northern bound, okay, so we have a Bukit Merah exit, okay. Near to the Bukit Merah exit, there are one slope structure, and another one, if I'm not mistaken, yeah, also on the same area towards the northern area. Okay. Where extrapolation is necessary, the designer should determine whether the rock mass and discontinuity pattern in the area of the data collection is akin to those of the slope by considering local geological condition. Okay, independent check on slope stabilization. Okay, so if you have, for example, experience, if you have master, okay, so you need to have experience at least 10 years in geotechnical work. Okay, so no need to have, I'm not sure, I guess no need to have a PE, full PE, what we call practicing PE. Okay, or you have a PhD, so you and then you experience in more than 5 years, okay, in geotechnical work, so you can be appointed as the independent geotechnical checker. Okay, so if I'm not mistaken, for the Johor Bahru area, okay, Nusa Jaya, okay, only 2 company is able to become the IGC. Okay, first is the one consultant, okay, headed by Dr. Azman Muhammad Amin, Azman Muhammad Amin, and another one is the Geotropic. Okay, so Geotropic is actually a center of excellence in UTM. Okay, so our team has I also the fellow for the Geotropic. Okay? So for the Johor Bahru area, so Geotropic and another consultant, okay, has been appointed as the checker under the Public Work Department of Nusa Jaya or JB. Okay.
Dr. Safa, is it under
Yeah.
BEM? The
Sorry?
geotechnical checker, is it a critical geotechnical checker, same as BEM?
I guess no, it's
No.
not. It's unnecessary. No.
All right.
Yeah, I guess under BM, GNP, HASB, okay, is among of the independent checker for the geotechnical structure. But for the slope, as long you have this kind of experience, okay, for example, for me, okay, I also a PE, but without practicing, okay, and I guess due to my experience more than 5 years in geotechnical work, so that's why the JKR allowed us to become the IGC. Okay. Okay, earthwork field material. Okay, material used in the construction of field slope and embankment shall, if it is suitable as far as possible, to those excavated from adjacent cut. Okay. So for the field material, we need to, for example, for the embankment, we need to refer to the suitable material. Okay, under the arahan, and under the road. Suitable material for the field material for the road construction. The road excavated from the cuts may be used as material for field if they are crushed to acceptable grading envelope. Okay. Drying out the field material during hauling and handling from cut to position of the placing should have to be allowed for. Okay. So settlement analysis. Okay, settlement analysis should be carried out for the field, slope and embankment design of field or amendment should be based on 90% settlement during construction. If ground improvement method are used, the settlement analysis will consider the type of the ground improvement method used. Okay, the total settlement for 7 years post-construction should be referred to table 2. Okay. So this is the table 2, okay, in the what we call it in the this guideline. Okay. So they provide, for example, the bearing capacity, the factor of safety value. Okay. So for the slope, okay, and also they also provide for the movement, for example, the vertical, okay, lateral and differential or angular, okay, the angular settlement, which is 1 to 150. So we may get, for example, what will be the angle, okay, of this ratio. So for unreinforced slope, okay, so this is cater for all type of geotechnical criteria. Okay. For example, for the unreinforced slope, okay, so the factor safety is 1.3, okay, and then if they are filled, so it become 2.0. Okay. So this is very general. Okay, so if you want to get more detail, so we need to refer to the Geo Hong Kong. Okay, I can provide the manual in the e-learning. Okay. Okay, for the embankment of soft ground. Okay, so this is the value for the settlement. Okay, less than 100. Okay, within 10 meter from the bridge approach. Okay, less than 250. Okay, for the road embankment. Okay, slope stability analysis. Slope stability analysis including establishing design criteria and performing calculation will be required for all cut, fill and natural slope. The data to be utilized in the slope stability analysis should be based on the detailed site plan, detailed field description, on-site exploration data and laboratory test data. It is the responsibility for geotechnical engineer to determine the weakest potential failure surface based on the above factor. In performing any analysis, the worst possible condition must be utilized. Okay. So I guess this is a common slope stability analysis. Okay, slope stability analysis shall include stability analysis for the temporary stability measure during construction. Cut and fill stability analysis should include both circular and non-circular analysis in multi-mode of failure. Any slope that influenced by surcharge shall be analyzed taking into consideration of this surcharge load. Okay. So this is related to the failure mechanism and also for the surcharge. Okay, this is for the rock slope. Okay. So they list all the type of stabilization. Okay. I will show later. Okay, the type of stabilization method. Okay, for the rock and also for the soil slope. Okay, so this is for the cut slope. Okay, all untreated slope should be designed with minimum 2 meter. Okay, so this is the berm. Okay, width. So we need to make sure that it is 2 meter width and maximum 6 meter berm height with a factor safety greater than 1.3. Okay, for example, if the slope is too high, so for every 6 meter, so we need to have a berm with a 2 meter and make sure it is more than 1.3. Stabilization measure can be considered when the design is inadequate. Okay, so this is type of stabilization. Okay, I will also share later. Okay, what is the soil nailing? Okay, anchor, retaining wall. Okay, the minimum global factor for treated slope should be 1.5. Okay, due to the maintenance reason and to minimize risk to the user, the maximum number of berm for cut slope should be restricted for 6 berm. So 6 times 6, 36 meter. because for every 6 meter, one berm should be constructed at 6 meter height. So 6 times 6, 36 meter. Okay. So in Jelapang, I guess it's more than 6 berm. Okay. So we need to climb. Okay. For example, to carry out for resistivity. Okay. To carry out for the conventional geological mapping. Okay. Okay, if the design shows that more than 6 berm are required, other solutions such as tunnel, rock shape, bridge shall be considered. Okay, so this is for cut slope. I guess for a soil slope. Okay, also for the rock. Okay, also for the rock. But for Jelapang, it's more than 36 meter height. So all untreated field slope and embankment should be designed with 2 berm. Okay. So this is for the field slope embankment. So this is for cut slope. So a little bit difference in terms of stabilization methods. Geogrid, reinforced concrete, reinforced field structure, replacing the field with elevated structure. Okay, so the rest is a little bit same. Okay, 2 berm, 6 meter, okay, up to only 6 berm. So if more than 6 berm, by a bridge viaduct should be considered. Okay, drain, surface drain. Okay, so this is for surface drain. So there will be another one, subsurface drain. Okay, horizontal drain and drainage blanket should be provided for cut slope. Okay. So reinforced structure, okay, according to BS 8006, the type of foundation for the reinforced structure should be designed based on the subsoil profile and the technical property of footing subsoil at each location. Okay, so this is the table 2. Okay, which I already shared before. Okay, so this is a development in hilly area. Okay, actually I based on Dr. Gui paper. Okay, I guess the Penang government has appointed him, okay, to look on to propose or to come with the guideline. Okay, so this is the buffer zone. So make sure that any structure or any building, okay, should have a buffer zone, okay, which is greater than the slope height. Okay, so I guess this is a new guideline for the Penang, and it can be used for any other location in Malaysia especially. Okay, so this is for the stabilization method, okay, or slope remedial works. So they divide into 5 category. Okay, for first one, retaining structure, slope stabilization, surface protection, rock slope, and others. Okay, which is not a common type of slope remediation work. Okay, so this is a rubber wall. Okay. So actually I get it from the JKR when we discuss on the Sabo Dam. Okay, so this is Sabo Dam. Okay, actually in Malaysia we only have 2 Sabo Dam. Okay, first at Kuala Kubu Baru and another one in Sarawak if I'm not mistaken. Okay, so now government want to build or construct for another Sabo Dam at Ian, Kedah. Okay, so UTM and USM team, okay, has been asked to prepare for the concept design for the Sabo Dam. Okay. So I am the head of the Sabo Dam design. Okay. Yeah, actually I just refer to some of what we call as literature. Okay. Especially from the Japanese researcher. Okay, so then we come up with the sabodem, what we call open type sabodem. But in Malaysia, in Kuala Kubu Baru, they use a closed type sabodem. Okay, so this is the rubber wall. Okay. This is typical drawing for the rubber wall. So this is the gabion wall. Okay. So this is the type of retaining structure. Okay. Istana Syarqiyah in in Terengganu, Kuala Terengganu. Okay. The castle for the Terengganu King. If not mistaken, the castle cost about 1 billion. Okay. Include all these retaining structure and also the castle. Okay. So this is a common type of gabion wall. Okay, then we have a reinforced concrete wall retaining structure. Okay. So actually, when I submitting my PE report, so I'm using this retaining wall for the design part. Okay. So it very simple, okay, but it can contribute if you want to apply for your. It can help you when you want to apply for your PE. Okay. So this is a reinforced concrete wall, retaining structure. Okay, so this is the sheet pile. Okay. Pusat Tenis Nasional Tun Razak. And then we have here reinforced earth wall. Okay. Okay, this is hexagon type. So Nehim, what you call it? The one that pattern this type.
Nehemia.
Nehemia. Malaysian, Malaysian.
Malaysian. Yeah.
Actually, the idea, do you know the idea is from the B, from the B, because this hexagon is the if I'm not mistaken, hexagon is the most optimum area that can that you can search on the hexagon type. So this is the most maximum. I'm not sure what is the term that we can get the most close area or cover. Okay? So that's why they use this hexagon type. Okay? Actually, the B use this hexagon type to build their nest. Okay?
Doctor, may I know the reason why a certain retaining structure is being picked for a certain slope? I mean, does the slope geometry plays a major role, or do they look at the type of soil?
Okay. So actually, it's based on the height of the slope. If I'm not mistaken, if you want to use this type of retaining structure, okay, so the height of the slope should not greater than 6 meter, if I'm not mistaken. But in this case, it's more than 6 meter. For example, for the retaining, for this retaining structure, okay, so it's not greater than 6 meter. Okay, if more than that, it's not suitable to use this retaining structure. At the same time, we want to maximize the area. For example, if we build a parking lot, okay, and then it's not very so for example, if you want to, this is this is, for example, this is an existing area, okay, or we have a different height of area, okay. So, but for example, to maximize the area, so it's not it's not suitable to have a slope, okay, with a normally 1 to 2 is 1 to 2 is the safe what we call safe or the stable slope. Okay, so in order to maximize it, so that's why they come up or they construct a retaining structure. Okay, but the retaining structure should not more than 6 meter height. Okay, boleh?
Boleh doktor. Terima kasih.
Okay. So this is creep wall. In terms of the idea, okay, how they choose either reinforced earth wall, creep wall, sheet pile, or anything type of retaining structure. A part of the a part of the reason is might be the cost of the construction. Might be gabion wall is not very expensive compared to the retaining wall. Okay, but it require a lot of area. Okay. So it depends on the cost, area, okay, and the aesthetic view. Okay, for example, for this case, if not a proper maintenance, so it's not look very it doesn't have any aesthetic value. So maintenance as well, maintenance. So this is less maintenance. This is the Benoit. But all of this is depend on the lateral load, okay? The capacity, the load that transfer laterally. Okay, so we need to calculate. For example, for the retaining structure, so we need to calculate for the stability, overturning, and also the bearing capacity. The sliding, the overturning, and also the bearing capacity. Okay, this is a continuous bore pile, so it can more than 6 meter if I'm not mistaken. Okay. So for this type of construction, so it can is suitable for more than 6 meter height. Okay, so this is slope stabilization. Okay, this is for the retaining structure. So this is for the slope protection for the surface. So we have a ground anchor. Soil nailing. With a short creep anything. Soil nailing and a tie back wall. Okay. Soil nailing and a grip beam. Okay. So for if you are using the GeoStudio, so we can easily what we call as design for the soil nailing. But I'm not sure to design for this grid beam. Okay. Concrete canvas. Stone pitching. Okay, so this is another type for the surface protection. Okay. Rock fill surface protection. Okay, so another one is the gabion mattress. Okay, So for example, if you want to design by using the GeoStudio, so you need to know what is the type of material that you want to use, and then you need to know what be the thickness. Okay. For example, when I design for rubber wall pitching, okay, so I just put 24 kPa, 24 kilonewton. Okay, sorry, unit weight 24 kilonewton per meter cube. Okay, to represent for the rubber wall pitching. So geosynthetic, okay. So this is another method for surface protection, especially for the field area. Okay, then we have here hydroseeding. Okay. So I guess they spray the seed, okay, the grass. How about the effective? Okay, so we design as a concrete material. If I'm mistaken, we can set for the concrete material. Okay, then we have a closed turfing. Okay. So this is for the rock slope. Okay, rock wall fencing. Rock boat. Okay, rock netting. So this is at Lebuh Raya Pantai Timur. Okay, this is Sabo Dam. Okay, in Jalan Kuala Kubu Baru. Okay, so this is Sabo Dam to prevent. So they use a pile because yeah, it's, the construction is located in the rural area, so it's not easy to bring the common span piling machine. So in that case, they use the micropile. Sabo Dam to prevent or to minimize the effect from the debris flow. Okay. Yeah, for example, for example, the incident in Yan. Okay. When the debris flow, okay, what the design load consider. Okay, the design load consider is the, for example, is the boulders, okay, and also the wood, okay, and also the what we call the hydrostatic pressure, okay. So we need to consider the load from this type of boulders, from the woods, the trunk. I'm not sure what is the term for this for wood. Huh? Okay, and also from the hydrostatic pressure from the debris flow. Okay, and this is the rock shed. Okay, I guess this is the only one in Malaysia. Jalan Simpang Pulai. Okay. Okay. So it's prevent from the rockfall.
Doctor, for the rock shed, I think another one in a Greek, Greek to Kelantan. That's another one.
Oh, jeli tu.
Jeli, yes.
Simpang Pulai. Okay, this is Simpang
Sorry,
Pulai.
Simpang Pulai pula. Sorry, jeli Greek, sorry. Jeli Greek satu.
Ni satu Jalan Simpang Pulai ni, satu. Yang ni ke bukan?
Ini I think Tak pasti. Ini baru ni, simpan pulai Canberra Highland ni rasa. Ya, ini simpan pulai Canberra Highland ni.
Okay.
Kalau another one, Jelly Creek.
Jelly Grade. Okay.
That one the first one lah.
The first one
Ah.
Okay, thank you. Okay. So that's for the design guideline for the slope design. Okay. I will share for the Hong Kong manual later on. Okay. So we will have a break for 10 minutes. Before we move for the two more slide, two more topic. Sorry.